Okay, 7-4 is talking if we have parallel lines in basically any figure that we've got here, and basically what we're going to look at here is a triangle. So if basically we have a line in there that's parallel to one of the parts of the triangle, it creates proportional parts. Taking a look at this picture that we have here, well, we see triangle ABC, and then AC and DE are parallel. And what that basically does is sets up a lot of proportions for us as to how those pieces have to go. Make a good note, though, that it doesn't necessarily work for the parallel lines. Pretty much any of the other pieces, and we can set up a proportion for it. But stay away from the parallel lines for now. We're going to learn about that a little later. So why don't you go ahead and fill in that information that we have there. That's BD, where is that? There it is. 4 AB, so the whole thing. 7. BE is X, and EC is 4. Now, you can set up a lot of proportions here. There's not just one way of doing this. But I think a lot of you are saying, okay, so CE is 4, but it'd be nice if we knew AD then. Well, do you know AD? Yeah, we can figure that pretty easy. Because if the whole thing's 7 and that much of it's 4, this much must be 3. So if all I have to do is find X, again, there's a lot of ways you could set this up. It depends on how basically you want to do it. Does anybody see a pattern that perhaps they would like to try? Nothing? You don't have anything you want to try? Well, how about this? We go 3 over 4, like that, equals, if you follow that pattern, what do you have to do? 4 over X. Like I told you, you pretty much have a lot of freedom with triangles. And how are we going to solve this? Well, that's 16, 3x, divide by 3. X is, does that come out evenly? No. How many times does 3 go into 16 without going over? 5, and how many left over? 1. So 5 1/3, or those of you slightly dependent on the calculator, 5.3 with the 3 repeating. That might be the easiest way to set that one up, but by no means the only way. A much more difficult way you could have done it is you could have said 4 to 7, and I'm doing this 4 right there, to that 7, and then you would have to go X to, again, I'm showing you another option in case you have a more difficult one that you have to do this. I want to make sure you do it right. Well, basically, I took the little piece times the whole thing, right? So how would I set up that other? Would be X, and then what's the other piece? Austin, I think I heard it from you. X plus 4 would be the whole thing, right? So 4 right here, and then whole thing 7. Down here it's X, and the whole thing's X plus 4. Now let's face it, if you had the choice between solving the blue one here and solving the red one, you're probably going to stick with blue. Okay, but it is the same idea. All you have to do is start the pattern and finish it. But which lines did I tell you to avoid at this time? The parallel ones. Other than that, as long as you follow it, you're fine. But it is important that the lines must be parallel. So in this one, there's another theorem. It says if the parallel segment hits the midpoint of the other two sides, then the length of the parallel segment's half the length of the third side. Wow, that's really wordy. Holy cow. Well, let's take a look at what that means. It means it's hitting the midpoint. Well, let's find out if it is. AE is 6, and AB is 12. Is it hitting, or is E the midpoint of that segment based on that information? Yeah, because it's 6 and 6. Okay. So now here we've got CD is 5, DB is 5. Okay, all right. Tells us that AC and ED are parallel. All right, tells us ED is 7. Determine AC. The only time I really want you to look at those parallel lines if it's this setup, if it's telling you it's the midpoint. And up there it says, if it's hitting the midpoint, then the length of the parallel segment is half the length of the third side. Well, this down here is the third side, right? So it's saying that one right there has to be half that length. So then how long is x if 7 has to be half of that? 14. Now see where you're saying, you know what, I don't really necessarily see that, Mr. Bokus. Well, what we're taking a look at is the top triangle is 5 to 6 to 7, correct? That's the top triangle. And the bigger triangle is what? Well, that's a bad picture, but 12, and then what's this side on the right? 10. So what would that one down on the bottom be? If you set it up, would it be 14? This is kind of just a shortcut of getting you there. Now, does this work on any problem? No, the lines have to be parallel, and they have to hit the midpoint of those sides. So would that have worked with the first example that we had? No, you couldn't have done that. Okay, so that's the only time I want you to look at the parallel lines. Okay. Any questions so far? Okay. Well, now it's saying, it gives you a bunch of information. It says determine if E, D, and CB are parallel. Well, let's put the information in and find out. CA, all right, is 15. CE is 3. DA is 8. And AB is 10. Well, if they are parallel, that little pattern that we chose to do should work, all right? And remember, so whatever pattern you want to start with, as long as you follow it, you should be fine, as long as you stay away from those parallel lines or the ones you think might be parallel. So let's see here. We could do, well, we know how much AE is. AE has to be 12. And D, what letter is that down there? B, is 2. And now you have even more proportions you could set up if you want. Some people kind of like to go like this. They say, well, let's go from 2 to 3. And then they say, does it equal? And if I do 2 to 3, you could do 8 to 12, or you could do 10 to 15. Very good. Okay. Any of those would help you check. Now, does this actually work out? Are they proportional? Are they the same? Well, that's 20. And that's 24. Well, those two are working out pretty good. How about these two? Do these work out? That's what? 120. Does it equal that one? Is that 120? It is? All right. So what do you think? Do those two lines over here have to be parallel then if all those proportions are working out? Yeah, they have to be. So it says determine, and I would say yes, they are. Now, what if just one of those messed up? Well, then you'd say no. Okay. But these were all good. Any questions? Well, we know they're parallel. And then some people would say, well, this topic has only told us if it's in a triangle. Well, couldn't I finish off the top for you and kind of turn this into a bunch of triangles for you? They could if you want. So it will work. So we have to determine x and y. Huh. Well, we got 6 and 8. At least that's good numbers to start with. So, wow, how are we going to do this then? Well, we know 6 to 8. Why don't we just say we know that one for sure, so let's get that one written down. Well, if I want to, I could do the same thing on this next line. Unfortunately, though, it'd be x plus 3 over 2y plus 6. What's not so good about that particular choice? 2 variables, right? We want to try and avoid that if we can. But I could also do it for the last one, and then last one we got x over x plus 5. So that's basically one way we could set this up. Do any of those help? Is there one we could actually solve any combination of these fractions here? If you pick just 2 of them, is there any that's actually going to help us out? Yeah, there actually is. Basically, let's kind of forget about that one for now and say let's use these. Now that we have it set up, is it okay to reduce these fractions? Yeah, do you think that's a good idea here? Yeah, as long as you do it right. So if we have 6 over 8, what number goes in there? So what, a 2 goes into both of them? So we got 3 over 4, right? So now 4 we would take times x. Now, remember the big mistake people will do going that way. All right, it is really 3 times x plus 5. If you forget to distribute, you're going to get a really wrong answer for x, and unfortunately in this problem, then you're going to get y wrong as well because of how this one's set up. So before x equals 3x plus 15. And, well, now we've gone from a picture that was kind of complicated to fractions, which, well, they weren't looking much better. But now we're to something that's more on the algebra that we're used to. These cancel. X is 15. Okay. Well, now that I know x is 15, any x in this problem has to be 15. Well, I think probably the best place to try and substitute that in is for this one right here. Let's replace that x with 15. Because then how much is that little segment right there? If that x there is 15, this is 18 right there, right? Well, that makes it a little easier. So again, we could go 6 to 8 equals, now we would do 18 to 2y plus 6. Is it again okay to simplify 6 over 8 if we wanted to? Yeah, we're here now. We're to where we have to solve, so that's fine. And I'm hoping it's 3/4 again. Hopefully, right? If we did that. So, well, 4 times 18, that's a little bit more complicated. Anybody know 4 times 18? 72, yep. Equals, now we got to take 3 times that. I'm running out of room in a hurry here. So we'll move up here. 72 equals, what do we got there? 6y plus 18. Subtract 18. Well, 72 minus 18. Does that work out okay? What do we get there? 54? So 54 equals 6y. Are we thinking this is going to work out okay? Does it have to? Does this have to be a nice number here? No. Did we get 5 1/3 earlier? I mean, this doesn't have to be 9. Divided by 6, y must be 9. And if you really wanted to check, you could, substitute it back into all the places and made sure they worked. All the proportions worked out. But once we got it set up, that really wasn't that bad. But you notice how I put the one with 2 variables in it right next to it to see if I could throw you off. Okay. Are there any questions?